In this video, I'm just really going to highlight a few points of what you're going to be seeing in this chapter and maybe help with a couple of the critical thinking questions. So, what is climate? It's pretty complex. It is not just the measure of temperature in the atmosphere or the measure of wind over a long period of time. It consists of 5 parts. It has the atmosphere, which we've been talking about all term. It has the hydrosphere. Think about it as the oceans, the rivers, the lakes, the cryosphere, the lithosphere, the biosphere. And each one of these interacts with the other to create the system of climate. So any one of these has an influence on the overall climate. So remember, there's 5 different aspects of the climate here. And climate variability is basically a short-term change in climate. And while climate change is long-term, something that lasts for many, many years, thousands probably, or hundreds anyways. So looking through this, we've been talking about climate change. The news media has been talking about climate change. And the idea is that for the last 3 decades, temperatures have been significantly warmer across the globe. So instead of just, 5 years or 10 years or 20 years, we're talking about a total of 30 years at least, probably going on 40 because this decade is definitely in the same ballpark. So 40 years of temperatures that are consistently above anything that we have historically. And that's only, basically 100 to 120, 140 years of record. So in climate sense, it's still relatively short term, but it is something to pay attention to. Where's all this warming going? You think about it, it's going into the ocean. The ocean is a great sink of energy. It stores energy like crazy. That's why when we're talking about hurricanes in the future or tropical cyclones in the future, there's this extra energy that's there, absorbed by the oceans. And that energy may be manifested in future tropical cyclones. It's something that the research is really looking into right now. So think about it. The ecosystem, living organisms have an impact on climate just because the way we farm or the way we do things all has an impact to change how things work. And climate change has an impact on us. So short-term would be like a big eruption of Pinatubo, which occurred in about 1991. Look at how cool it got for the next 3 years. Then it began to go back up to normal. During this time, temperatures all over the United States were below normal for this time. Most of these years, especially in the summertime. So there have been a number of papers written. I don't know if you've noticed in the news about all the papers that are being written about COVID-19, but the papers that stand up to the test of time seem to be the ones that have been reviewed by peers. And I know when I published papers, I had at least three other authors that reviewed my paper, came back with comments, and tried to replicate what I did before I was allowed to publish a paper. Those are the kind of papers that make sense because other scientists have reviewed your work and have verified, assuming they're reputable scientists, what you did as something that's worthwhile. So there is a method to this. So let's just look at a couple things here with science and global. One of the things is the global radiative equilibrium. It still holds. The same amount of energy is arriving as the same amount is being stored here. But with the warming that's going on, less and less, maybe infrared is getting sent back out. So we're actually absorbing more solar radiation. And how is that? The only way it's possible is through greenhouse gases. That's just something to think about. There are changes that occur to solar radiation. and they seem to relate it to sunspot activity. So if that is the case, that might be a natural driver of when some climate changes occur. And you can look at minima and maxima here of sunspots. And they talk about the moderate minimum was greatly reduced sunspots and really cold times. So it seems like sunspots, the more sunspots, the warmer it is, the less sunspots, the colder it is. However, we've been in a minimum here for a little while, and yet we've been getting warmer. So it'll be interesting to see how that all plays out in the future. It's something to think about, though. There have been ice ages, and there are things called Milankovitch cycles. Basically, they reflect the tilt of the Earth slightly, and eccentricity as our orbits change. They occur over tens of thousands of years. They're very, very not something we're going to see in our lifetime. But the total amount of radiation coming into the Earth is the same. It's the distribution of that radiation that changes. So that is a key point with this. There is a distribution change of that radiation. One of the other things, plate tectonics can play a role. And there's feedback mechanisms in here as well. And that's where I wanted to go to with this. Think about it. If I got rid of all the snow and ice, and we've learned that ice and snow are highly reflective, what's going to happen? Well, things are going to heat up more, right, over that landmass. Well, that's what's happening in some of the poles. Think about the oceans up there. In the Arctic Ocean, if you get rid of the ice, the Arctic Ocean is going to begin to absorb more energy because it doesn't have that reflection, so it's going to heat up faster. So it's a feedback mechanism that way. Now, if you begin to increase the ice and the snow, it's going to cool down. So you have both happening and both ways to happen. But right now we're going the wrong way, maybe, or at least a warming mechanism. And we found more clouds and all might impact it. So there are climate models. There are all kind of climate models, and I did modeling more on a short-term basis when I worked. There are things called, like this model, COAST, which joins an ocean model, an atmospheric model, a wave model, sediment transport, to study long-term things. They don't look necessarily at individual days. They look at individual months, maybe, to try to determine how climate is changing. How's the atmosphere changing? How are the oceans changing? What's going on? And with that, they might run out 200 years over the course of time to get a view of that. There are all kinds of these models. Here's just one physical one showing Rossby wave formation. And maybe they're just tracking the Rossby waves. That there are all kinds of global climate models. Each one's improving. And what they do is try to look back maybe at the last 50 years of weather and see how their model compares to that data, and then project it out maybe the next 100 years, 200 years, just to see how things are going to change. And just like any set of ensemble models, where we've talked about that in the last chapter, where the more ensemble models have a better chance of predicting what's actually going to happen, an ensemble of climate models, too, is going to have that probability of the weather will actually occur within that grouping. So the more and more global climate models that we have out there, the better chance we can actually understand what is going to happen with the future. And with that, part of that as well, they may track individual aspects of the future weather, such as tropical systems, such as how many times cold fronts. What about droughts? Or how are they going to change? All these are interesting questions that are still being explored. And with this, if climate continues to change, well, what about sea level? How will the oceans interact with this? Will ENSO change? Again, all things that we're looking at in these climate models that maybe in the future we'll have a better understanding of. So you've been through this whole course now. One of the biggest challenges now left for you is the signature project. I really look forward to reading your papers about Sandy. Uh, think about what just happened with this tropical system that just came up the East Coast. In some ways, it's not unlike that. Matter of fact, some of the winds that occurred in New York City were similar to winds that occurred in Sandy. So maybe you can even look at drawing parallels between the two systems. I really want to see your information because I want to see how you utilize what you have learned in this course to look at a weather event, to have an understanding of it that you never had before. So let me know if you have any questions. Thanks for attending. I hope you got something out of it.